Hey, algebra students. Here in lesson number 4, we're going to be talking about partial fractions. And this one is definitely a lesson where it's going to increase your algebra fluency. Um, However, and while there are some connections to calculus, this one, not a whole lot of real life applications to it. So, here we are. We are going to find the partial fraction decomposition for rational expressions. Essentially, we're going to start with a rational expression and we're going to turn it into its original fractions, where if we would have added those together, it would give us the final rational fraction. So, here's how it goes. You guys know what a rational expression is. It could be something as simple as like 2x plus 1 over maybe 3x squared plus 4x. We've worked with rational expressions a lot this year. We've added them, subtracted them, multiplied, and divided them. Today we are going to take them and we're going to split them up. We're going to turn them into their parts. And so that's essentially what decomposition of rational expressions is. We're going to start with a rational expression and break it up into its parts. So I'm going to kind of explain this to you as a very simple example. So let's say we had something like 3/5. This is not a rational expression, it's just a ratio. But I think you'll get the idea best from this. It's basically saying, all right, well, let's turn this into its parts. This would be the same thing as like 1/5 plus 1/5 plus 1/5. Okay, I'm breaking it down into its original parts. 1/5 plus 1/5 plus 1/5 would of course be 3/5. So everything that we've done so far kind of goes this direction, but today we're going to go the opposite direction. So our partial fraction decomposition is this thing right here. That's the partial fraction decomposition. The process is called the decomposition of rational expressions, and each one of these individual things right here is called a partial fraction. So that's the goal today. All right. I'm going to give you two examples of things that you could get, or I guess two separate types of things. This one is called an improper example, or not improper example, improper fraction, because you'll notice that the numerator, or I guess the degree in the numerator, is bigger than the degree in the denominator. Just like if you had something like 4/3, this would be an improper fraction. So what we are going to do, step number 1, okay, is we're going to divide. Now this step is only for improper fractions because we can factor something out, we can divide something out. So step number 1 is to divide, and we're going to go ahead and just do that. That's something that we've done throughout this year. We've got x cubed minus 4x, and then inside the box we've got 2x to the 4th minus 8x squared plus 5x minus 2. All right, well, we think to ourselves, what can I multiply x cubed by to get 2x to the 4th? And the answer to that is 2x. And then we do the multiplication here, so we get minus 2x to the 4th. We multiply and then we change the sign. And then 2x times negative 4x would be negative 8x squared, and so change the sign, we get positive 8x squared. Now you'll notice that these things both cancel out. And so our remainder is actually 5x minus 2. So we have 2x and then remainder, I guess not remainder, we'll put it as a fraction. So 5x minus 2ths over x cubed minus 4x. Okay? So the first step, we've divided this, putting it into its partial fractions. We kind of have one part of it, but now we just have a regular proper fraction that we're going to have to decompose. So step number 2, what we're going to do is we're going to go ahead and take this fraction right here, And we're going to work with that. We're going to decompose that. And so we're going to say, all right, 5x minus 2 over x cubed minus 4x. And we are going to, at this point, we are going to factor the denominator. Okay, so what's that look like? Well, if I had, maybe I'll do the work over here. If I had x cubed minus 4x, okay, I could factor out an x, in which case I'd wind up with x times x squared minus 4. And you'll notice that that is a difference of squares. So I could turn that into x plus 2, x minus 2. All right, and then I'm going to take this denominator and I'm going to split it up into its factors to make my partial fractions. So I'd have a over x, and then plus b over x plus 2, plus c over x minus 2. Okay, so I've got all three of my factors that would combine to make this guy right here. And now my mission is to solve for a, b, and c. And of course, that doesn't look too great. All right, let's see. Now we get into a lot of the algebra stuff. So step 3, we are going to multiply by the denominator. Okay, specifically this guy right here. And why would we do that? Well, that's going to, because all three of these are factors of this, it's going to basically eliminate all the fractions. So I've got x cubed minus 4x, and then as I distribute that to each one of the terms inside here, okay, well obviously it's going to cancel this out because that's what it is. Okay, I could also think of this as x times x plus 2 times x minus 2. Okay, that'll help here in a second. But that would leave us with 5x minus 2. Over here, notice the x would cancel out with the x, and I just have the x plus 2 and the x minus 2 times the a. So I wind up with x plus 2 and x minus 2. And then I've got the b. You'll notice that the x plus 2 would cancel out this x plus 2. And so I would have b times the other stuff, which would be x and x minus 2. And with the third one, the x minus 2 would cancel out. And so I'd be left with c times, and then I'd have x and x plus 2. Okay, well, this is a nice, big, long equation, but at least it doesn't have any fractions in it. Step number 4, we're going to go ahead and pick some values for x. Pick x values. And the reason why I'm going to pick some x values is because when I plug some x values in here, specific ones, things will cancel out and I'm going to be left with maybe some values for a, b, and c. So the first thing I'm going to pick is x equals 0. In fact, the numbers that I'm going to be picking for x are the numbers that would actually make things not work here, the things that my denominator can't be, like 0, -2, and +2. So when x equals 0, I plug that in everywhere I see the x, and watch what happens. I get 5 times 0 minus 2, which is -2. And then over here, well, when x equals 0, I get 2 times -2, which is -4. So -4 times a. However, watch what happens with the rest of it. When x equals 0, this whole thing goes away because that goes to 0. And then over here, same thing. This whole thing goes to 0 because I've got times 0. And so divide both sides by -4, and I get a is equal to +1/2. All right, so I got one of my 3 values up here. Now I need to find another one. Let's go ahead and try x equals about -2. or sorry, positive 2. That would be, no, let's do negative 2. Negative 2 will work here. So what happens when I plug in negative 2? Well, I get 5 times negative 2, which is negative 10. Minus 2 is negative 12. And then as I plug in negative 2, well, notice this term right here, if I plug in negative 2, well, I get plus 2, it's 0. So this whole thing goes away. When I plug in negative 2 here, I get negative 2 times, well, negative 4, which would be positive 8. So this is going to be b times positive 8. But then over here, again, I plug in negative 2, that goes to 0, so the whole thing goes to 0. And then I divide both sides by 8, and I get b equals negative 3/2. All right, and then the last one, x equals positive 2. Well, when I plug in positive 2 into this equation, I get 10 minus 2 is positive 8. But then you'll notice that this would also go to 0. 2 minus 2 is 0, so the whole thing goes to 0. This one, same deal. 2 makes that go to 0, so it all goes away. But here I get 2 times 4, which is positive 8. So c times 8, divide both sides by 8, and c equals 1. All right, well, now that I've got my a, b, and c value, I just have to plug those back in up here to get my final answer. And so, pick x values, and so we'll finish up step 4. Pick x values and solve for a, b, and c. And then step 5. Step 5 would be go ahead and plug in your a, b, and c. Okay, c. All right, and so as I plug these back in, or actually, more likely what's going to happen is, again, the whole idea was that I decompose this guy. So I'm going to start by saying, all right, if the original thing was 2x to the 4th minus 8x squared plus 5x minus 2 divided by x cubed minus 4x. Well, this now equals, well, don't forget that way back in the beginning here we had a 2x. So we've got the 2x out in front, or 2x over 1. And then we've got plus, and now we got this whole bit right here. We've got a, which is 1/2. So that means I'm going to put 1 over here and then 2x in the denominator. And then b was negative 3/2. So I've got negative 3 over 2 times x plus 2. And then finally plus c. And c was just 1, so 1 over x minus 2. All right, so this is the partial fraction deconstruction, decomposition. These are the fractions that make up this guy right here. All right, moving on to the second example, and this one is an example where you have multiples. So we'll call this one the multiple example. And, well, we'll do our best to kind of follow along with the same steps on the previous slide. Of course, this time it's a proper fraction, so I don't need to do any division. I can just go straight to setting this up. So I can say 2x over x minus 1 cubed. And here's how I break up the denominator, or factor it out. We're going to say a over x minus 1, and then plus b over x minus 1 squared, and then plus c over x minus 1 cubed. So, I'm starting with the basic here, then I repeat it, and then I repeat it 3 times, getting up to what I had here originally, and this is going to make things cancel out. So, again, here's what we're doing. Step number 2 was go ahead and multiply through by your denominator here. So, x minus 1 cubed. And, well, when I do that, clearly it would cancel this out, and I'd just be left with 2x. And then over here, I'd have a. But, here, cubed, this would be like to the 1. When I divide exponents with the same base, I subtract, so it would be x minus 1 squared. And then, I've got b, and then 3 minus 2 is 1, so that's just x minus 1. And then here, the cubes cancel out the entire cubed, so I get plus c. All right, so I've written it now without any fractions. Now I need to pick values for x. And, well, I've got 1 that makes sense to me right off the bat, and that's x equals 1. So let's go ahead and do that. We'll say we'll pick x equals 1 as a value. And when I plug in 1 into this person, or in this equation here, I've got 2 equals. And then notice, well, that's going to cancel out. This will also cancel out. And I'm just left with c. Hey, look at that. c equals 2. That's great. Unfortunately, the rest of them are not quite as simple. Now, the others, you have to pick on your own. You pick. Okay? I liked the other one because I knew exactly what to pick, the things that made this 0, but I only had one value here that made that 0, so this time I'm going to pick stuff that's just easy. So I'm going to say x equals negative 1. When x equals negative 1, and I plug that in here, I get negative 2. And then negative 1 minus 1 is negative 2. Negative 2 squared is 4, so I've got 4a. And when I plug in negative 1 here, I get negative 2, so minus 2b. And I already know that c is equal to 2, so I'll also say plus 2. And if I subtracted 2 from both sides, I could now call this negative 4 equals 4a minus 2b. Now, that doesn't actually solve for a or b, but I'll just keep watching. I'm going to pick another value for x. Let's say x equals 0. Now, when x equals 0, I can go ahead and plug that in here. 2 times 0 is 0. And then 0 minus 1 is negative 1. Negative 1 squared is positive 1. So I have positive 1a. And then when I plug in 0 here, 0 minus 1 is negative 1. So minus 1b or minus b. But then again, I got plus 2. And if I subtract that 2 from both sides, I get negative 2 equals a minus b. Well, notice what I've got here. I've got a system of equations. And so I'm going to go ahead and solve this system of equations using elimination. I'm going to multiply through the bottom by negative 2. And that would give me, well, at the top would stay the same, negative 4 times 4a minus 2b. Then on the bottom I have positive 4 equals negative 2a plus 2b. And so you can see here the b's will cancel out. I've got 0 equals 2a, and so a would have to equal 0. That's great. I've got A, I've got C, now I just need to find B, and that's not going to be so hard. I'm just going to go ahead and plug this back into any one of the convenient equations. I think, let's see, I think this one would probably do. So I've got negative 2 equals A, which is 0, minus B. Well, that means B just equals positive 2. And so I have now figured out my A, B, and C. So let's put this all together. We had the original thing, which up here was just 2x over x minus 1 cubed. And the deconstruction. Well, we know that a is 1, or sorry, a is 0. So 0 divided by anything is 0. That one actually goes away. B is 2, so I have 2 over x minus 1 squared. And then plus c, well, c is 2, so 2 over x minus 1 cubed. And that's my partial fraction decomposition. All right, enjoy.